class, we're about to start lesson 7, graphing a line from chapter 6. It says use the coordinate system, we can graph equation. Well, using the coordinate system, we can graph equations. When the equation has only two variables, x and y, and neither is raised to an exponent, the graph of the equation will be a line. When the graph of an equation is a straight line, the equation is a linear equation. To graph an equation, you need to solve for 2 points on the line. Example 1, graph the equation y equals 3x minus 4. Now as you see here, what they did was they let x equal be 1, let x equals 1, and then they also let x equals 2. So what we did here, we substituted. In this equation, we substituted in 1 for x and then solve for y. And that gave us the ordered pair here, 1, negative 1. Then we let x be 2, and then we solve for y. And our point is 2, 2. So then they plotted the points on the graph here. You have 1, negative 1, and then you have 2, 2, and then drew a line. So basically what it's saying is that you could substitute in for one variable and solve for the other. You cannot just make it up for each variable. So with that being said, if we look at example 2, it says some linear equation problems don't require you to draw a graph. Now it says here, point A lies at 5, negative 6 on a coordinate grid. The graph of which of the following equations passes through point A? So what they want you to do, they want you to substitute in 5 for x and negative 6 for y and see which one works. So with that being said, we could go here and it turns out it looks as though it was the second equation that worked. So we substitute in 5 for x. So you got negative 4 times 5, which is 20. Well, negative 20. Plus 14 will give you negative 6. So when x is 5, y is negative 6, and that was proven. So now we go down here to the practice problems. It says fill in the y column in each table and graph the equation. Now, what I'm going to do, I'm going to fill in the y column for all 4 of these problems, but I think I may only graph 2 of them. So let's go with number 1. We have y equals 1/2 x plus 3. So I'm just going to draw a table here. We have x, y, and we have negative 2, 0, and 2. So now what we're supposed to do is substitute in for x and then solve for y. So we have y is equal to 1/2 times negative 2 plus 3. Now we know this is negative 2 over 1. So y is equal to a negative 1/2 times a negative 2 over 1 gives us negative 2 over 2 plus 3. Negative 2 over 2 is negative 1 plus 3, and y is equal to 2. So our first answer is negative 2, 2. Now we go to the next. We'll take the same equation and this time substitute in 0 for x. So now we have y equals 1/2 times 0 is 0 plus 3. So y is equal to 3. So we have 0, 3. Now we go through and substitute in 2 for x. So we have 1/2 times 2 plus 3. So now we have 1/2 times 2. So we'll make that 2 over 1. So that'll give us 2 over 2 plus 3. 2 over 2 we know is 1 plus 3 is 4. So now these are our points after we solve. So when y is when x is negative 2, y is 2. When x is 0, y is 3. And then when x is 2, y is 4. Now I'm going to graph this. Now I would tell you this, but each one of these tick marks is considered to be one space. So basically here we know this is the origin. We'll go to the right. This will be 1, 2, 3, 4, 5, 6, 7. To the left, -1, -2, -3, -4, -5, -6. And I'm going to add one more to make it -7 so I can keep this balance. Here on the y-axis, 1, 2, 3, 4, 5, 6, 7. And then down here on the y-axis, we got -1, -2, -3, -4, -5, -6, -7. And I guess I could just leave that -8. That's fine. Okay, so now we graph. We go to the origin, and then we go to the left 2 because x is -2, and then we go up 2 because y is 2. Now we start at the origin. X is 0, y is +3. We go 1, 2, 3, and we put our point here. Now we start back at the origin. We go to the right 2, then we go up 4. 1, 2, 3, 4. Now we graph it. So that is our line. Now, of course, it'd be a lot better if I had a straight edge, but you get the point here. Okay, problem number 2. We have the equation y plus 3x equals -1. We have the table x and y. Then we add -1, 0, 1. Now we go through and substitute like we did with the first problem. We have y plus 3 times -1 is equal to -1. We have y minus 3 equals -1. We add 3 on both sides, and y is 2. So when x is -1, y is 2. Next, we'll substitute in 0 for x. So we have y plus 3 times 0 equals -1. So it'll be y plus 0 equals -1. Y plus 0 is y, and then say y equals -1. So when x is 0, y is -1. Now we go to the next. This time we'll substitute in 1 for x. So we have y plus 3 times 1 equals -1. So we have y plus 3 equals -1. We'll subtract 3 on both sides, and y is -4. So now we're going to graph this. Okay, so we start at the origin. We had -1 and +2. So we go to the left 1 and up 2. Start back at the origin. We have 0, -1, so we go down 1. And then here, we go back to the origin. We go to 1 and then -4. And then we connect these points. And this is our graph. All right, now I'm going to do number 3, and then we're going to move on. So number 3, we have -2 plus y equals -x. All right, now we have our table. We have 0, 1, 2. So now we substitute in these values for x. So we have -2 plus y equals negative, and we'll make x 0 here. So we have -2 plus y equals 0, because we know the opposite of 0 is still just 0. So we add 2 on both sides, and y equals 2. So when x is 0, y is 2. Now we go here to the next problem. So now we have -2 plus y is equal to the opposite of +1. So we have -2 plus y equals -1. We add 2 on both sides, and y is 1. So when x is 1, y is 1. Now finally, we substitute in 2 for x. So we have -2 plus y equals the opposite of 2. So -2 plus y equals -2. Add 2 on both sides, and y is 0. Okay, now What I didn't do in problem 1 and 2, I'm going to write it and let you see it. But what I should have done after we solved all these was to put them as ordered pairs. So this here, when x is 0, y is 2. So we write that as an ordered pair. When x is 1, y is 1. And then here, when x is 2, y is 0. And then going back up here, this should have been -1, 2. This should have been 0, -1. And this should have been 1, -4. Then I'll go here on the back as well, and I wrote down these ordered pairs for you. Okay, now we just need to graph number 3. Okay, now we draw a graph. All right, so we start at the origin. We had 0, 2. So we'll go up 2. And then we go back to the origin. We'll go 1 to the right, 1 up. And then we'll start at the origin. We'll go to the right 2 and a 0. So now we'll connect these points. And that is our graph. Okay, so now we're going to move on. We're going to go down to problem number 5. This is B. It says choose the one best answer to each question. Questions 5 and 6 refer to the following coordinate grid. It says the graph of the equation y equals 1/4 x will pass through which of the following pairs of points. Okay, now, of course, I'm not going to go through all of those problems because that will take up a considerable amount of time. So, what I am going to do, I'm going to pick out the answer and then show you what you were supposed to do in order to get there. Okay, so now, with this problem here, the answer to number 5 would be, let's see, problem number 5, it'll be C. So number 5, we have y equals 1/4 x, and we have to find points that will work on this graph. So now, if you look at C, they gave us 0, 0. Now remember, 0, 0 is significant because I told you that is the coordinate of your origin. So what we would do, we would substitute in 0 for x and 0 for y. So we had 0 is equal to 1/4 times 0. So this would be 0 equals 0. So remember, whenever we put in our point, it must make this equation true, and it makes it true. So that's why your answer is C. The rest of them, if you would have tried them, it would have made it false. So number 6, it says line P, which we see here, line P, is the graph of which of the following equations. So we could take one point off of line P and then see if it works here. So let's just take this point here. This would be -1, and then we'll go up 2. So we know one ordered pair is -1, 2, and then we could take this point 2, which is 0, -2. Okay, so now we would take these and put them into the equation and then make sure that they work. So I would tell you the answer is D, but I'm going to show you why it's D. Okay, so now, the answer is D. So what we did, we would substitute this into the equation. So y would be 2, and x here would be -1. So it's 2 equals -4 times -1 is +4 minus 2. And 4 minus 2 is 2. So 2 equals 2. So we know that works. So then the second order pair has to work as well. So y would be -2 and x would be 0. So it'd be negative 2 is equal to 0 minus 2, and negative 2 equals negative 2. So that would take care of number 6, and that's why it's D. All right, now we're going to go here to problem number 7, and this is the last problem for this section. So number 7, it says point C is located at negative 3, 5. A graph of which of the following equations would pass through point C? So point C is negative 3, 5. So they want to know which one of these lines would pass through negative 3, 5. So what we would do, we would put these values in. If it makes the equation true, then that lets us know that that is part of the answer. So if we look here at number 7, the answer for number 7 would be B. It'd be the y equals 2, well, I'm sorry, it's not y equals, it's 2x plus 3y equals 9. So we will put in our negative 3 for x and our 5 for y, and that equals 9. So this would be negative 6 plus 15 equals 9. Negative 6 plus 15 is 9, and 9 equals 9. So that is why our answer is B. So this is the end of this problem, this section here. And have a wonderful day, and I will upload this to YouTube.